Hello everyone, hope you guys doing well. In this videos and couple of other videos we are going to discuss about basic definitions which are mentioned in 62443 standard. Now these definitions are very important in terms of application of 62443 during risk assessment, design and implementation as well as maintenance activities. So some of the definitions shall be very clear, and in my practical experience when I was with OEMs, even many of the teams in OEMs are not very clear about these definitions and they interchangeably use these nomenclatures. Using is fine, but during the applications of 62443 these definitions matter a lot. So let's start with this, and we will cover the basic definitions in couple of videos. Otherwise in a single stretch it will be longer video. So I'll break this into a couple of videos and I'll cover these definitions. Okay, so part 1 of basic concepts of 62443 and the application of these basic concepts. Now in this slide deck we will cover very basic 3 important definitions, that is components, systems and solution. Now the understanding of these 3 definitions is very important when we are performing risk assessments, design and implementation and maintenance part of it. So when we say components, we are talking about discrete elements in industrial automation and control systems. Now there are 4 types of components as per 62443 4-2. Your embedded systems, your network devices, your software applications and host devices. Right? And these 4 components, these 4 types of components make up the next level of next layer of industrial automation and control system, that is your systems. I'll come to systems, but before that let me complete components. Now when we say components, these are assessed or certified by OEMs as per 62443 4-1 and 62443 4-2. So it's all about example PLC. It's all about how the PLC has been developed. So first question, how this particular device under consideration is developed as per what best practice? For that question, OEMs generally answer that we have developed this device under consideration as per 62443 4-1. That is your secure development life cycle. The next question is, do you have all the controls as per the established security level capability SLC? The answer for that question, which OEMs generally answer, is yes, we have concluded that our device can match security level capability 2 and all the relevant controls as per 62443 4-2 has been implemented, and all the process of good processes while implementing these controls have been followed. So that is components. When we talk about systems, as I mentioned, these components get together and formulate a system. Little complex to assess this. Again, components and systems are within the purview of OEMs. They are the people who are going to manage the life cycle of these components or systems. Now systems can have components from the same OEM. When I say same OEM, it's definitely not the same team. Every OEM, Schneider, Siemens, Honeywell, Rockwell, ABB, name it, they have multiple BUs, and within BUs they have multiple teams. Even though they are in the same company, but they have different cost centers or business units. So the systems team talk to each of these components team, the project managers or the project team or product owners who are managing these components, and take these components to formulate their systems. Good example of systems is distributed control systems or burner management system or building management system. So that's why we have system in that while describing those group of components. Now these systems have a very specific utility. They're meant for specific utility. Example, DCS for safety critical systems, which are having very tight knit devices. They communicate within certain time frame, certain milliseconds or microseconds. And these systems, all the components of these systems are managed by the respective OEM. As I mentioned, these systems can have the components from the same company, or they can also have components from their partners. This is why I mentioned it becomes complex, because when we are assessing these systems, we carry out risk assessment as per 62443-3-2. That's why I mentioned as implicitly included. We also formulate zones and conduits within the system. Please note, it is not site, it is a system, still in the lab of OEM. So we formulate those zones and conduits. And when we are including the components from the third party or partners, then we depend on the assessment methodology as well as evidences from the third partner. It's very difficult to ascertain all this practically. So we have to take into account that many of the things are on not very evidence-based, but certificates based on mutual agreement. So when we formulate the systems and we deploy these systems, let's say, to the end customer, the lifecycle management, be it update management, version management, be it decommissioning or end of life, all those things are managed by the OEM who is supplying this system, not the product owners of an individual component. Internally, definitely, the OEM, this particular OEM who is supplying this system, will be contacting the product suppliers. Again, here two set of questions are answered. The first set of question is, how did you develop this system? Have you followed all the good practices? The answer for that by an OEM is yes, I have followed 4-1, that is security development lifecycle. Now, the second set of question is again similar to your component. Have you implemented all the controls as per your concluded security level capability? Remember, in components and systems, we are talking about security level capability. That's what OEM is trying to build, capability. That's why we, in the standards 4-2 and 3-3, we find SLC. We don't have the scale for SLT or SLA. So as I mentioned, we have to also formulate zones and conduits in systems. That's why we also have to include 3-2. That's where your zone and conduit requirements are mentioned. This is a typical approach we also follow while we are certifying. So in ICS Bit Labs, we have helped a couple of OEMs to certify their products. And this is the approach which the accredited labs who are certifying or organizations who are certifying also agree with. This is by book. Coming to solutions become a little more complex. Now solution is group of systems by different OEMs coming together to address a specific automation problem for an asset owner. So here we critically talk about the zones, conduits, risk assessment, design and implementation of the complete plant example. Example here is a solution for solar power plant, which my team is currently working in Middle East. And that includes various systems supplied by different vendors. Approximately some 10-15 vendors are involved here while supplying various systems. The integration of all these systems is from my partner, who is managing the implementation of all these automation. The cybersecurity part is with me, where I start from the very beginning. I will be onboarded with these guys, and that's where right from the design, right from the assessment, and design implementation, my contribution will be there to fine tune as per the compliance part, 62443 compliance. When we talk about solutions, here the system integrator or largely service provider is responsible to talk to many of all these participant vendors and ensure the interoperability of the various systems which are participating in this solution. Likewise, the service provider also have partners or subcontractors like us who will contribute in ensuring that it is as per the good cybersecurity practice by book, that is 62443 standard. When we talk about solution, generally we talk about, let's say it's a green site, green field, and we are talking about the complete plant. We start with the very assessment of design which is proposed, and that is as per 62443 3-2. But here almost all relevant standards are involved, because when we are designing a green field, it is just not implementing IDS, be it NIDS or HIDS, your endpoint solutions, or your EDR solutions, your firewalls, routers, switches, your data diodes. That's all good, but that makes up only 33% of the problem statement. Rest 66% can be again segregated into people and process. So the ultimate objective of building a solution as per 62443 based on risk assessment is again to help the secure design implementation, and the ultimate objective of secure design and implementation is to enable secure management of the security posture while the operations are going on, that is maintenance phase. So ultimate objective of maintenance phase again feeds back to your cyber security program, that is CSMS as per 62443 2-1. So if you touch 2-1, you eventually start touching all the other documents in 62443. I think this video is a little longer, but I have covered very important concepts here. These concepts, so I have exemplified or explained in detail that why these are important in applications as well, application of 62443 as well. Thank you. See you in next video.